Good morning, students. Welcome back to my seventh lecture that is related with your environmental engineering subject C701. The topic of today's discussion is the quality standards of water. It's a very important topic. Earlier we were in the discussion of the demand of water, population forecasting, then the source of water, groundwater, the surface water we have seen. Now, the quality standards of water is a very important and interesting phenomena which we civil engineers vis-a-vis the environmental engineer must be aware of the characteristics of the waste of the water for use as a drinking water, so that we should know what are the permissible values. First of all, let me go through the concept of some terminology, basic terminology, whether we will accept or reject the water for our drinking purpose. Now, what are those? The thing is the wholesome water. Let us acquainted with all the terminologies terms. The terminologies, that is the wholesome water. What do you mean by the wholesome water? It is not chemically pure, but does not contain anything harmful to human health. It should be free from bacteria, colorless, tasty, should not corrode pipes, free from all objectionable matters, should have dissolved oxygen. These are the things of characterization of the wholesome water. That means this water, definitely, if we it is not the water which some salts may be there. So that's why at very beginning I mentioned that it is not chemically pure, but does not contain anything harmful to human health. Second terminology I am going to tell you, that is the palatable water. What do you mean by palatable water? The water which is tasteful for drinking and aesthetically pure is known as the palatable water. So this is the tasteful as well as aesthetically pure. Now, what is potable water? The water which has both the characteristics wholesome water and palatable water. So that will be that we usually use as our drinking water. So again, I am telling the potable water, basically we are taking it as our drinking water. Why? Because it is basically aesthetically as well as tasteful. Not only that, it uh, does not carry any impurities which is detrimental to our health. That means it is not carrying any harmful to human health. It is not carrying any content which is harmful to human health. So that is a combination of the wholesome water and the palatable water is called the potable water. Now, what is polluted water? The water which consists of undesirable substances which make it unfit for drinking and domestic use. Generally, we are rejecting this water, we will not take as a drinking water. Contaminated water. The water containing pathogenic organism is called as contaminated water. Contaminated water is always polluted, but polluted water does not necessarily mean it is always the polluted water. So polluted water, contaminated water is always polluted, but polluted water may not necessarily means it is contaminated water. So this is the thing, the basic terminology of wholesome water, palatable water, potable water, polluted water, contaminated water. These are the terminologies which you are using regarding the quality of water, whether we will accept or reject the water. Now, if we go on parameter basis, each and every parameter basis of containing in the water, in engineering sense, which will see what will be the value of the acceptable value as per the IEST code 10,500 is concerned, the drinking water allowable content parameter that we call the characteristics. So generally three characteristics of water are there. One is the physical characteristics, second one is the chemical characteristics, and third one is the microorganism in water. So physical characteristics, the first characteristics I will discuss, that is the physical characteristics of water. Physical parameters of water, as the name indicates, by physical observation, we can arrive the characterization of the water, like color. As a physical loop, we can see what is the color. We can make the comparison of the. I'm coming back to all the details in details. First of all, let me just highlight what are the parameters under the physical characteristics or physical parameters. Color, as we see physically, so obviously it's a physical characteristics. Taste and odor, by taste and odor means smell, so it is also by physical observation. So we are feeling the quality of the water which will be acceptable or rejected for the drinking purpose. So these are the taste and odor, also the physical characteristics vis-a-vis the physical parameter of the water. Temperature of the water also we can feel whether it is hot or cold. So this is also under the physical characteristics. Turbidity. Turbidity means how turbid the water is. That means the turbidity we can visually inspect, visually classify the characteristics of water as a turbid water or not. So these are the parameters, basic parameters. There are other parameters also like conductivity are also. So these are the parameters generally are very much useful to find out in a laboratory test for taking the decision in treatment unit. So what is the color? Another is the taste and odor. Third one is the temperature. Fourth one is the turbidity. Under all the physical characteristics of water. Coming to the chemical characteristics of water. Total solids, dissolved solids, suspended solid, volatile solid. What do you mean? That means the water content, how much solid. There also every parameter has some acceptable value, has some permissible value in the IEST code. What are the acceptable value of the IEST code? Acceptable value means generally we will accept the value within the acceptable limit which is given as an acceptable value in the IEST code. What is then the permissible value? What is the difference between permissible value from the acceptable value in the IEST code? When there is no alternative source, what have to be done? One, when there is no alternative source, then only if the alternative source is there, then we have to choose for other alternatives for check the acceptable limit of that particular parameter. But when we have no option, when there is no alternative source, so in that particular case we can go in specific or in special condition up to the permissible value. So that is the difference lies between the acceptable and the permissible, whether you have in your hand the alternative source or not. Now the chemical characteristics, total solids, dissolved solids, suspended solids, volatile solids, all will be discussed while detailing of the descriptions in your chemical characteristics. Chlorides, hardness. Chlorides means how much chloride content, what will the impact if the chloride content is more. Hardness, then the pH value, then the metals and other chemical substances, nitrogen and its compounds, and finally the dissolved gas under the chemical characteristics. Now, just to give you a brief before going to the detail, that chlorides means it is basically if the chloride content is more, then there will be an effect in staining on the clothes. It's basically a salt. It may create the corrosion on the pipes when throwing the water, drinking water line. So it will have some impact which will be reduced. Again, the minimum chloride values is required for our health. We cannot make it as a zero. So that value will be discussed. Then hardness. More the hardness means more the soap consumption will be more. That means in detail it will be discussed, but to give you a hint, what is hardness? Hardness is a property which is a property of water which resists the formation of foam or leather by the soaps. That means more hard the water, it will be more resistant to making the foam or leather by the soap. So soap consumption automatically will be increased. So soap is the example. By consumption of the soap, we can judge whether the water is hard or not. Not only that, hardness of water will have an impact on scaling formation in the boiler, because in boiler we are using water for producing the steam. Then pH value is the minus log 10H, that means inverse of log 10 hydrogen ion. So pH value determines whether it is the hydrogen concentration is more or hydroxyl concentration is more. That means pH value gives us the solution is the water is acidic or alkaline. So that is determined by the pH value. So metals and other chemical substances, then nitrogen and its compounds and dissolved gases all are under the chemical characteristics. And lastly, I will discuss the microorganisms in water. Now physical characteristics first, I will discuss the color. When I discuss the color is of two types. One is the apparent color and another is the true color of the water. It is a physical, by physical observation you can see the color of the water. So this is under the physical characteristics of the water. Now what is apparent color? Apparent color is due to the presence of organic material from decaying vegetation or inorganic material presenting colloidal suspension. And the true color is the same thing if it in dissolved, that means in true solution. So one is in dissolved solution which is giving you true color, and another one is in the suspend condition whether it is in apparent color. Now apparent color can be easily removed. How? Because that materials which are in suspension, that can be expelled out by placing it in a I would to say the centrifuge. Centrifuge means the centrifugal action force is there. If you but what I'm telling you that in apparent color you can remove by expelling the suspended matters by placing it in a centrifuge, and by vortex motion it will by centrifugal force that suspended matters which creating the apparent color that may be expelled out from the solution, that from the aqueous solution, and make it a true color. So that temporary color can be removed. There is a process. So what is the standard unit of the color? Standard unit of the color is Hagen, which is produced by, what is Hagen? Then Hagen is defined by 1 milligram of platinum cobalt. If we dissolve 1 milligram of platinum cobalt in 1 liter of distilled water, then 1 unit Hagen it gives. So as per 10,500, the acceptable limit of color, if you see the drinking water parameter, the allowable limits and the permissible limits, acceptable limits, the corresponding code is IEST 10,500, and there it is mentioned that the color acceptable limit for drinking purpose is 5 Hagen and the permissible limit is 15 Hagen. What is 5 Hagen? If there is an alternative source, so 5 Hagen we have to stick. If there is a one source of water, because we don't have any other option, we don't have any other alternative source, then we may have the permissible limit 15 Hagen. But if it beyond that, then you have to reject the water even if you have no source, single source. So this is the difference between the acceptable limit and the permissible limit as stipulated in the two columns in IEST 10,500. So drinking water, the acceptable limit of the color is 5 Hagen and the permissible limit is 15 Hagen. The apparent color due to turbidity, as I have told you, removed by the centrifuging mechanism, because this is placed in the centrifuge rotating at a very high speed, so the vortex motion spills out suspended matter, as I told you earlier. So when the apparent color is being left due to the centrifugal force, due to the vortex motion, then the color left in the water is only the true color. So color is reduced or removed from water through the use of coagulation. This type of true color, that means the responsible waste particulate matters are the dissolved particles which are responsible for forming the true color. So this true color can be removed from water through the use of coagulation, settling and filtration technique. That will be discussed in the treatment process of the water. This is not the topic for discussion. We are today only discussing the quality parameter of the water, that is the characteristics of the water for drinking purpose. Now next physical parameter, physical characteristics of water, we will discuss the taste and odor. These are due to presence of mineral salts, dead and live microorganisms, dissolved gases like H2S, CH4 means hydrogen sulfide, methane, carbon dioxide, or oxygen combined with organic matter due to dissolved organic impurities such as phenols, chlorophenols, etc. etc. And the odor may be classified as fishy, sweetish, vegetable, greasy, etc. etc. The water having bad smell or odor is objectionable and should not be supplied to public. Taste is measured as flavor threshold. Now, what is the unit? How the taste is measured? Taste is measured as flavor threshold number, that is FTL, and odor, that is the smell, is measured at threshold odor number TOL. For example, I am just clarifying the idea of the threshold limit of that both taste and odor. If 6 cc centimeter cube, 6 cc means 6 centimeter cube of water, if you are added to 100 cc 100 centimeter cube of fresh water, that means distilled water, which you have no giving no order, if it is giving no order, fine. But somehow if I increase the dose rather from the 6 cc, that means more than 6 cc water when added, 200 cc fresh water gives order in that diluted sample, then threshold number will be 6. That means what we can conclude, threshold number is that number beyond, just beyond which the order started. Up to threshold number, no order is there. After threshold number, the order started. So this is the thing. So threshold, it is expressed as a threshold number. Now the temperature. Definitely the order, if objectionable order, there is no numerical value in the IIEST code. Only thing it is mentioned that objectionable order should be, if there is an objectionable order, that water sample will be rejected for taking as a drinking water. It should not be supplied for drinking water. Now temperature. The next physical characteristics is the temperature. The temperature of water to be supplied should be approximately between, it is fixed between 10 degrees centigrade to 20 degrees centigrade, because beyond the 25 degrees centigrade, quite it is really an objectionable and it is considered an objectionable. The increase in temperature, what will happen if the temperature increase? If the increase in temperature decreases the palatability, which is in taste form, we can see it is present in taste. Definitely, more the temperature, the taste of the water get reduced. And some volatile gases, why this is happened? Because some volatile gases which are responsible for the taste are expelled due to high temperature. Temperature is also important to identify the magnitude of the density, and directly we know that the density, viscosity, vapor pressure, surface tension of water are related with the temperature, surrounding temperature. So this temperature will affect the characterization of the water also. So generally acceptable range of the temperature is 10 degree to 20 degrees centigrade. And another thing, dissolved oxygen content in the water, which purifies the water, that is also affected by the temperature. Now I will discuss the turbidity. What is the turbidity? Very important phenomena. Turbidity is caused due to the presence of suspended and colloidal matter present in water. Again I repeat, suspended turbidity is due to presence of suspended and colloidal matter present in water. What do you mean by the colloidal matter? Negatively charged fine particle which cannot be seen in open eye, which can be seen with the microscope. So very, very fine negative charge colloidal particles, that are called colloidal matters, and these are not easily settleable, these are not dissolved, always stay in suspend condition, so that's why they make the turbidity. So basic theme is due to suspension the turbidity arises. Suspension of what? Suspension of that colloidal matters. The character and amount of turbidity depends on the type of soil over which water has. We know the water source are the two. One is the surface and another is the subsurface, that is the groundwater. So definitely when water flows on the surface, I am talking for the surface runoff. Suppose surface runoff means the surface source of water. Definitely it will flow over various soils. So as it will flow over various soils, so definitely it will contain much more colloidal particles, so which for which the water becomes turbid. But if we say the groundwater, it is less turbid compared to the surface water. Now, how the turbidity is measured? Turbidity of the water is measured. Turbidity is actually gives the resistance of water to the passage of light through it, because the particles content in the suspension condition, in the water, that particle will object the light path. That means that scatters the light, so that will resist. More the turbidity means more suspended particles are there, colloidal suspended particles are there, that means more resistance of water to the passage of light through it. So this is the thing I am saying, that turbidity actually measures the resistance of water to the passage of light through it, and it is expressed as ppm. What is ppm? ppm means parts per million. In nutshell, it can be said milligram per liter. 1 ppm means 1 milligram per liter. So but let us discuss about the unit. What is the turbidity unit? Now, turbidity produced by 1 milligram of silica, that means silicon dioxide SiO2. If I put 1 milligram silica in 1 liter of distilled water, it is 1 unit of turbidity. Nephelometers is a digital turbidity meter. That is, the nephelometers are the modern turbidity meters in which the light intensity is measured at right angles to the incident ray. That means it scatters at right angles to the incident ray. A photometer in this instrument measures the intensity of light passing through the turbid water after the same is scattered at right angles to the incident ray. So by this mechanism, by this scattering of light, the equipment, that is the turbidity meter, nephelometric turbidity, directly give us in digital display what is the turbidity of the water by scattering the light phenomena. So as for IEST 10500, acceptable limit of the turbidity in drinking water is 1 NTU, and permissible limit is 5 NTU. Same I am highlighting. What is permissible limit of 5 NTU? 5 NTU is the permissible limit of turbidity of the water for drinking purpose when there is an alternative source of water. When there is no alternative source of water. If there is an alternative source of water, then you have to stick with 1 NTU, that is the 1 nephelometric turbidity unit. So this is the thing. Earlier it was JTU, Jackson turbidity unit. Nowadays, modern days, in our modern science, now the nephelometric turbidity meter we are using, and the units are expressed in the nephelometric turbidity unit. These are all about the physical parameter, physical characterization of the water, which will give us to take the decision in treatment process. What will be the treatment process, that we will discuss on the next module, and whether this, as per the IEST code, limiting value of the drinking water, this water, whether we can accept or reject, and all these things will be physically experimented in our laboratories while carrying out the laboratory process of water. So now coming to the chemical characteristics, that is, first I will discuss the hardness, because in your exam this is very important. Hardness among the chemical characteristics, this is one of the most important that I would say, because the most questions, not only the short questions, short notes, MCQ questions comes from the hardness. The significance of this topic, hardness, lies in the fact that the maximum numerical problem sum is coming from the hardness. That is also added advantage of yours. You can solve the mathematical numericals if you have a concept on this parameter hardness, because it will be using in the softening treatment process when you will learn afterwards. Let's discuss the hardness definition. What is hardness? Hardness is, as I've told very beginning at the introduction of the characterization of all the characterization. Then I have mentioned that hardness, basically it is a property of water which indicate the resistance of water against formation of foam or leather in the while using with the water. What does it mean? Now it is basically prevents hardness of water, means it is a property which indicates that it prevents formation of leather or foam when mixed with soap. This is only the mechanism by mixing with soap. If we see that the formation of leather or foam is not formed easily, then we must uh, see that this water is hard. So this increase the amount of soap needed for washing. So more hard means that soap consumption will be more, and your amount of soap uses of amount of soap will be increased, and soap consumption will also be more. Not only the soap consumption point of view, but if we see that it forms the scaling on the boiler, on the pipe. Why pipes? Because in pipe the water flows for distribution lines, and if the water hard, so it corrodes the pipe, it forms scaling. Same thing in the mechanical equipment boiler, which is producing steam with the help of water. So if water is hard, then definitely it will be very detrimental to the boiler, as if damaging the boiler mechanical system by scaling formation. So that you have to take care the hardness of water which you are using in boiler and pipe, whether it is in permissible and allowable limit, that we will discuss very soon. It causes valves to stick due to the formation of calcium carbonate crystals. It leaves stains on plumbing fixtures. Now, hardness is due to what? What are the factors responsible for hardness in water? Basically, I can say the responsible factors are the divalent metal ions. Now, these divalent metal ions are forming the hardness and water. And what are the divalent metals? Calcium, magnesium, ferrous, manganese. So these are the others are also, but these are the some of the divalent metal ions which are responsible for hardness, that I am telling you. But in nutshell, I can show you the main divalent metal ions which are responsible for the hardness of water is due to calcium and magnesium. That means Ca2 plus and Mg2 plus. So these two giant metallic divalent ions, that means the divalent cations. I would say divalent cations, that is the positive ions. Ca2 plus or Mg2 plus, that is the calcium cations and magnesium cations. That two main divalent metal cations are mostly responsible for the hardness of water. And practically most hardness is due to calcium and magnesium ions, the predominant minerals in the natural water. So what to say by the hardness, total hardness? The total hardness is calcium ion hardness plus magnesium ion hardness. Other can be neglected for the computation purpose and for our practical experience, where the concentration of each ion is in consistent units such as milligram per liter as CSO. Yes, that hardness is expressed as CSO. That I will discuss that how the CSO3 as CSO3 can be converted from, suppose hardness of the water this amount of milligram per liter as CSO3, so it will be written as CSO3. So how we will convert as CSO3, that I will tell you. But let us acknowledge the thing, the classification of hard water, because among the hardness we can say this is a soft hard water, moderate hard water, very hard water. So how you would classify the water as different hardness, that is the soft hardness, moderate hardness, hard water, and very hard water. So 0 to 75 milligram per liter as CaCO3 or ppm plus ppm as CaCO3 is called the soft hard water. What is moderate hard water? Now 75 to 100 milligram per liter as CaCO3 gives the moderate hard water. Similarly, for hard and very hard, we can say 100 to 380 milligram per liter as CaCO3 and more than 300 milligram per liter as CaCO3. So this is the thing. You can classify knowing the hardness, whether it is a soft water, soft hard water, moderately hard water, or very hard water. Now, this picture I am showing you that how the formation of hardness is formed. Now, topsoil, bacterial action, carbon dioxide, subsoil. Now, limestone is there in soil. So, all this combination due to carbonate and bicarbonate, these hardness are formed. But remember, I have shown the calcium and magnesium ion. Now, carbonate and non-carbonate hardness. What is carbonate hardness? It is called the temporary hardness. So in hardness, there are two types of hardness. One is the temporary hardness and one is the permanent hardness. What is temporary hardness that I am discussing, that is abbreviated as CI, that means the carbonate hardness. That is carbonate hardness of calcium and magnesium ion. So I can say calcium ion and magnesium ion, if are associated with bicarbonate HCO3 minus or carbonate, they are producing the carbonate hardness. And why I am calling it as a temporary hardness? Because this temporary hardness, because this is in temporary nature. Because if we boil the water now, then the hardness will be removed. Why? Because precipitation will be done and we will get the fresh water where it will no contain the hardness. So temporary hardness can be easily removed by boiling. So I can say the carbonate hardness vis-a-vis the temporary hardness can be easily removed by boiling. So it is called the temporary hardness. But if I talk the non-carbonate hardness, which is permanent hardness, it can't be removed easily by simply boiling, because the calcium and magnesium here associated with chloride, nitrate, sulfate, and all these things, not carbonate bicarbonate. If it is carbonate bicarbonate, then it is a temporary carbonate hardness. If it is a non-carbonate hardness, that means due to the chloride ion or nitrate ion or sulfate ion, then these are the permanent hardness, which is called the non-carbonate hardness. So carbonate hardness is the temporary hardness, and non-carbonate hardness, for example, chloride, nitrate, sulfate, these are called the permanent hardness. Okay. So non-carbonate hardness is nothing but the total hardness minus carbonate hardness. If we know the total hardness, if we know the carbonate hardness, the difference between the two gives us the non-carbonate hardness or the permanent hardness. So hardness is determined in lab by which process, that will show in our laboratory. Just to give you the knowledge, very important question of your MCQ for your semester exam, that hardness is determined by titrating against ethylene diamine tetraacetic acid. In titration, two things are there. One is the titrant, which will pour in burette, and that is EDTA, that is ethylene diamine tetraacetic acid, and which will use for titration. And another thing is the indicator, and that indicator is EBT, that is eriochrome black tea as indicator. So these two parameters you have to keep in your memory. One is the titrant, that is the through which it will be titrated, that is EDTA, ethylene diamine tetraacetic acid, and it is used the I mean to say the indicator is used as a eriochrome black tea EBT. So these two things are required in the laboratory process for finding out the hardness of water. Now, as per IEST code, acceptable limit of total hardness of CaCO3 is 200 milligram per liter. Again, where the alternative sources are there. If there is no alternative source, then the permissible limit of the same is 600 milligram per liter. So maximum is 600 and the acceptable limit is 200. That value I have taken from IS 10500, the allowable limit code of the drinking water. So the hardness, the salts, actually the content of the salts, is required to our health to some extent. That's why the limiting value is 200 and 600. It cannot be zero. But similarly, as the problem I highlighted, the subconsumption will be more, the scaling formation in boiler, in pipe, then it also affects on the valve in plumbing fitting. So definitely the exceeding value or maximum value you have to take care. Now finally, when you go on problem numerical solve, you have to keep in our memory that total hardness, that means Ca plus, Ca2 plus due to Ca2 plus and Mg plus 2. So these two are divalent metallic cations which are responsible for formation of the hardness, and obviously total hardness means all the ions responsible for the hardness you have to add. But here I want to show you, as I mentioned repeatedly, that hardness is measured as CaCO3. So it is measured as CaCO3. So don't forget to mention as CaCO3. Suppose hardness of water is 400 milligram per liter is 0. Hardness of water equal to 400 milligram per liter as CaCO3. Since you are in scale of CaCO3 you are mentioning, that means one conversion you need to do here. What is that? Now calcium 2 plus Mg plus milligram per liter into equivalent weight of CaCO3 divided by equivalent weight of calcium. That multiplied factor you have to take care while calculating the hardness of water after determination in your lab. Why? Because ultimately you are expressing the hardness in CaCO3. So what is equivalent of CaCO3? Equivalent is nothing but the molecular weight by valency. So CaCO3, if Ca40 is the calcium, 40 molecular weight is there, and C is 12. OT means 3 into 16, 48. So CaCO3, the molecular weight gives us the 100. And what is the valency of CaCO3? 2. So what is the equivalent? Equivalent weight of CaCO3 is 100 divided by 2 is 50. Same thing, equivalent weight of calcium 2, calcium is 40 divided by 2 valency, that means molecular weight by valency, that means 40 by 2. So calcium equivalent weight is 20. So ultimately 50 divided by 20. So 2.5. So if you multiply it by 2.5, then we can convert the calcium hardness as CaCO3. So don't forget to multiplying factor, that is the equivalent weight of CaCO3 divided by equivalent weight of Ca. This is very important because ultimately we are converting the hardness of water as CaCO3. So next lecture I will continue with these parameters. That means the chemical parameters as well as next the microorganism parameters that I will discuss. So these chemical parameters of under the characterization of water will be continuing in our next lecture also. That is the lecture number 8 also of this subject C701. So my dear students, these lecture notes I will post in the Google Classroom. So that you can an option to repeatedly see, go through these lecture materials up to which in today's class we have discussed, and definitely will meet in the interaction live classes where the all questionnaires and the clarification will be discussed one by one in the live classes, and the assignments, numerical problems, MCQ questions which are probable questions in the forthcoming semesters. Definitely it will be given us once you go through these lectures, which will be given by you in your timely submission. Thank you. Have a good day. Thank you.